All right, welcome back, everybody. This is part 8 of the Bezier grass series, and today I wanted to talk about achieving a more natural blend at a distance. So in the previous video, we looked at culling the grass at a distance to get a smoother transition, and that can get us a large way there, but there are a couple of situations that it won't handle very well. At the end of the day, we can still usually pretty easily notice when the individual blades of grass are being culled because there'll be a variation between the underlying terrain and how it looks, how it's shaded, and how the blade of grass that is above it is shaded. So in this case, for example, we can see as we reach off into the distance, there's a pretty sharp line where we can see the shading of the underlying grass, especially if we're looking in the direction of the shadow, right? So this is looking at the underside, the shaded side of the grass. It's extremely obvious where that transition's happening. And then over here, it's not so bad because we're looking at the top side of the grass, which has a little less of a shading discontinuity. But the idea here is that the normal vector of the underlying terrain is pointed up directly towards the sky, right? Whereas if we look at any individual blade of grass, the normal vector of that blade of grass is not usually going to be pointed straight up. It's going to be pointing, in some random direction depending on the rotation of that blade of grass. And so this causes a discontinuity where the actual blade of grass as normal kind of disappears, and then we see the underlying terrain. So one thing you'll see a lot is people will just say, okay, well, if we want to get rid of that, then let's just blend in an upward facing normal, right? And so what this will allow us to do is get a transition where, let's say that happens over 8,000 units, right? So here we can see the real normal of the grass blending towards this upward facing normal. But there's a problem with this, which is that not all of our terrain has an upward facing normal. If we go much closer here on that transition so that it applies to this mountain, we can see that the normal here is not upward facing. So if we try to apply this, we effectively lose the shape of this hill in our shading. So you can kind of see that happen here, where here it's got some shading to it, and if I bring that in, now it's being shaded as though it's flat. So we don't want to do that. One way that this is commonly solved is by, and I'll also show you here, you can see that transition is now gone in the distance. You can still see it here, but that's just because of the PCG volume end, not because of the actual grass transition. So yeah, in any case, the problem with that is that not all the normals face up. And so some people have solved this in a couple of different ways. One example of that is to use runtime virtual textures. So you can output the actual normal of the underlying terrain into a virtual texture, and then your material can sample that virtual texture. The problem with that is, well, it actually works really well, but one potential issue is that sampling virtual textures is somewhat expensive, so I wanted to avoid it in this video. And also it's been done before, and I didn't want to just show things that people already know. So I'm going to show a different way of approaching this. So instead of sampling a virtual texture, we're going to do what we've done in the past here and bake that texture, or bake that that normal data into our instance so that it can sample it using PCG. So here I've got some, for instance, custom data nodes that are storing what we need to reconstruct our normal. And if we go ahead and go to our buffer visualization again, we look at our world normal, I go ahead and apply this. You're not going to notice any significant difference, but if I go ahead and bring this back in close, you'll see that that the normal vector of the terrain is preserved. And I'm actually going to do this in tangent space instead of instance and particle space. So you can see basically perfect. So here's the cutoff, right, where the real normal is being drawn. But you'll see that we've perfectly shown the landscapes normals on this grass. And it's working on the hillside here where we have this other color, and it's blending seamlessly out into the distant terrain, right? So that transition is completely invisible. And if I go ahead and set this back up to a more reasonable blend distance, we get that. So this will allow us to preserve the shape of our sloped hills and everything, but still get a nice blend with our landscape off in the distance. So now we get a really natural blend. So the way that this is done, as I mentioned, is using PCG. So let's hop over to PCG and look at what we're doing here. So in PCG, I'm taking the surface sampler, which if we think about our surface sampler, what that's doing is it's creating a point that is aligned to the normal of our landscape, right? So inside here, if we inspect this and we look at one of these points, we have these positions, X, Y, and Z, which is what we've really been utilizing so far, right? But we also have a rotation.roll, rotation.pitch, and rotation.yaw. So this is the rotation of our mesh. And we'll notice that the yaw is always 0 by default, so we can ignore that. But we have a roll and a pitch. So if we take this roll and we take this pitch, and I'm going to take rotation.roll as the input value, and I'm going to create I'm going to output it as, copy it as a variable called, or property called, or attribute, whatever they're called in PCG, right? Called roll. And then I'm going to take that, it's in degrees by default. I'm going to put that into radians, and then I'm going to perform a sine operation on it. I'm going to do the same thing for the pitch. Degrees a radian, and then sine. And then we're going to add the attribute back into our data set. So when we get to our static mesh spawners, we can look at that and see that we have a roll and a pitch value. In this case, they're mostly the same because this looks like part of the flat grass terrain. But if we go to maybe this one, you'll see a much wider variation. So these will be values that we can use to rebuild our normals. So if we go back to our grass material here, we can see that we're taking these values, which I've passed through using this, right? So our instance data packer type. So where we previously were creating our random values to encode in our instances, I've created 2 more, one for pitch, one for roll, in index 2 and 3. We go to our material and we grab pitch and roll, index 2 and 3 with our per instance custom data. We make that a float 2. We use the derived normal z to turn this into a 3D vector, normalizing that for good measure. And I found that I needed to just multiply that by -1, 1 in order to orient it correctly. But it might just be the way I set my mesh up. And then 2-sided sine so that we are not getting a back face normal on the distant grass. We want it all to point the same direction, whether we're looking at the top or the bottom, in order to fix some shading artifacts. And then we're going to transform that from world space to tangent space. You could also use instance and particle space, world space to instance and particle space, but then it would apply some rotation to it based off of the instance's rotation, which makes it gives a different look. You might like it, maybe not. And then I'm using a lerp over a distance in order to blend that with the real normal. So in this case, up to 1,000 Unreal units, we are using the real normal, and then it starts to blend over the distance of the entire grass to the underlying landscape's normal. And at the full culling point, which is 8,000 in my case, it's using fully the grass normal. And the way I'm calculating that is by taking the camera position, the distance between the blade of grass, and then using that. Now you could also use the pixel depth. I do want to kind of quickly illustrate a difference here. So if we look at, let's put this in the emissive color. So this is taking the distance between either like a blade of grass or the world position and the camera position. And what you'll find is, let's see, I'll probably need to, this is fine. What you'll find is that I get kind of a radius, right? If I come down. And what's nice about this is that as I rotate my camera, that radius is staying the same distance from the camera. So it's kind of stable in space as the camera rotates. If we were to use the pixel depth for the same effect, just due to the nature of how pixel depth is calculated, what we're going to get is not going to be a consistent radius. So you'll see here, as I move the camera around, it's kind of a flat projection based off of the different distance from that specific pixel rather than from the camera's position. So instead of getting a radius, we get this linear effect, which most of the time is fine, but sometimes that can cause noticeable changes in how the scene is shaded or lit based off of how you're rotating the camera, and that can look unsightly. So you can instead use the distance node to get the distance between either an instance or a pixel, and then we don't get kind of a change in how the scene is lit based off of our rotation. It is a little bit more expensive to calculate that, so use your judgment, but I think that can be a nice effect. It's kind of annoying when I see in games when the camera's rotating that the visual effects aren't kind of consistent. But I do also use the pixel depth in certain areas in this material, and it's usually fine. So in any case, going back to PCG, so that data is packed into an attribute, just like everything else, and our material reconstructs that normal, blends it with the actual normal before outputting it to the material. And we can get rid of this. So another thing we can do is really we want to make sure that we're doing the same with all of our all of our buffers, is we want to get them to match over time. So for example, if I look at the roughness, you'll see here that the roughness of the grass up close is relatively low. I want to get that kind of sheen to it, but at a distance, we want to make it look pretty rough, right? Because if we think about what roughness is, it kind of represents sub-pixel normal detail, right? So if we think about a normal map, kind of tells us what direction should a pixel be lit by, but if you look at kind of the microscopic level of what a normal actually is, roughness kind of approximates that, right? How rough the surface is how much light is bouncing off in different directions. So as the grass gets to a level where that shine would be kind of sub-pixel, we want to fade it away and represent that by a decrease in an increase in its roughness and possibly a decrease in its specularity. So over time, this grass is transitioning to match the landscape's roughness. And then the same could be said about the specularity. Maybe not as well blended here. I haven't really double checked these since it's been a while since I worked on this project, but you'll see that it kind of fades out. And then the same for the base color. So the far grass material just blends to kind of an average color of what the actual blades of grass are. So I took, what are the colors of these individual blades of grass, and you can actually see that here. So here are the two colors I was using for the blades of grass, and then was lerping between them. And then I said, okay, well, what is a value that is halfway between these two? And then I just grabbed that value and blend to that over a distance, but you could obviously make this a little more complicated. But the idea is that we want a smooth transition from our color. And so at the point where we can no longer really distinguish the individual blades of grass, we would want to transition to either like a noise texture or some sort of macro texture that contains, similar colors to get that seamless transition from a color perspective. And then we're also doing the same with subsurface color. So as it gets to the edge, the subsurface is faded out. I find that fading the subsurface out helps a lot for preserving the shape of the distant terrain, because if you keep the subsurface on, it will kind of stay lit up a little bit more, kind of give a transparent look to the grass at a distance that's not very flattering. So for the subsurface color here, we can see that here's the grass's base color. That's going in to a blend that's blending between the actual subsurface color and a value of 0. Actually, this is meant to be that. And so these blends are really convenient with if you're trying to do a distance blend, using inverse lerp and lerp is a really quick and easy way to do that. So you can take your range, so in this case, the distance between the blade of grass and the camera, and say, from the range between 1,000 and 4,000, and it will say anything below 1,000, is one value, everything above 4,000 is another. You want to saturate that because it won't clamp it in the 0 to 1 range, which is usually what we're going to want for a lerp. And then we can remap that range into the whatever range of values we want. So it's a really good way to kind of remap one value to another. And then that is just going into our subsurface here. And so with all of our values, we're kind of doing the same thing, right? So in this case, I'm using for the roughness and specular, I'm using the pixel depth rather than the grass distance. So let's go ahead and get rid of that. So let's say grass distance. Grab that instead. Get rid of the pixel depth. And that's happening between 1,000 and 4,000. But it could easily be 1,000 and 8,000, 1,000, 6,000, whatever you want it to be. And that's putting out our roughness and our specular. And I think this is also using pixel depth. Let's go ahead and get rid of that. Make it grass distance. If I'm calculating it once in the shader, I may as well use it everywhere. And that's pretty much that. So now we have a nice soft transition between our landscapes material values, right? So our landscape specular, and you can actually go in here when you're creating your material. You can say, okay, well, what is my distance specular, right? I want that I want to blend to that value. You can just go in here, take your color picker, say, okay, here is the value that I want to blend into on my specular, right? And then you use that for your lerp. And then you can get the exact value at a distance. But yeah, once you have your all of your values interpolated over a distance, you'll get a really nice smooth transition, and you'll also have preserved the shape of the grass. It'll, the landscape, I mean, it will work under really any lighting condition. We don't get these sharp edges. You can even apply, a normal map to the distant grass terrain to simulate the waves of the grass here as well, which I'm not doing, right? Because we can see here that the movement of the grass fades away, but you could actually apply a normal map to the distant grass and give it some kind of waviness if you really wanted to make a super large field where that grass was culled out, but still has the effect of blowing in the wind. But yeah, I think that's really all I wanted to cover in this video. This may or may not be the last video. I did kind of want to see and experiment with some other things. Don't know if I'll continue this or not, but if there's enough interest, we'll see what what you guys might want to see still. But that's all for now. Thanks again for watching, and have a good one.